Alright, so 3.4. Okay, we have velocity, and we have other rates of change. So this is kind of two things in one chapter. Okay, so the first thing we're going to learn about is related rates, and then we're going to talk about velocity and motion. Okay, we'll do velocity and motion tomorrow, and we'll talk about related rates today. Okay, so related rates. Okay, the idea of a related rate is taking a real-world scenario. So let's just say I have a balloon. Okay, and let's say I was going to take the balloon and blow it up. Okay, so the idea is the balloon is going to grow at a certain rate. Okay, and the radius is also going to be growing as well. Okay, so what I can analyze is I can find the instantaneous rate of change of the radius at a certain point when the volume might be a certain size. Okay, so when we're working with related rate questions, we are always going to be working in terms of time. Okay, so related rate is always in terms of time. Okay, so what that means, do you see this right here? d dt. Okay, everything that we've been doing so far has been in terms of x. Okay, I derive in terms of x. So I'm technically, if I was going to write the derivative of 3x squared, okay, would technically be 6x dx dx. Okay, now I haven't showed this to you before because what is dx dx? 1. Okay, so now what we're going to be doing is we're going to be working with these ideas of shapes. Okay, so maybe we have an equation for area. So give me an equation for area that you know. So I heard, I'm totally picking the easiest one I can think of off the top of my head. The area of a square is the side squared. Okay, so if I was going to derive this in terms of time, I'm going to derive both sides as a d whatever dt. Okay, so when I derive a, it becomes dA dt. Okay, when I derive s squared, what is the derivative of s squared? 2s. So I do my basic ds dt. So every time I derive any variable, I have that letter over dt. Do you see what I'm saying by that? Okay. It'll get pounded into your brain because we'll do it enough times. Okay, so the procedures for finding this related rate. So step 1 would be if you can draw a picture, draw a picture. Okay, we might be working with triangles. We might be working with circles. Who knows? You can draw a picture that helps you understand the spatial idea. Okay. Step 2 is write down anything that is given to you. Okay, so if they tell us when the radius is 5, we're going to say when r equals 5. Or when they say when the rate is 9, we're going to give that a piece. Okay. Then we're going to come up with the equation that we're trying to solve, and then we're going to derive it. Okay, so just so you know, there are a bunch of formulas that you probably know already. I would write the ones down that you don't know. Okay, I think that you know all of the right triangle stuff. Okay, you guys know that if we're analyzing a right triangle, we have a Pythagorean identity, right? A squared plus b squared equals c squared. The area of a triangle is 1/2 times the base times the height. You should know that. If you're working with a circle, the area of a circle is pi r squared. If we're working with the circumference of a circle, the equation is 2 pi r. Anybody know the stuff for a sphere?
It's like pi r cubed.
Okay, so V is representing volume. Okay, the volume of a sphere is 4/3 pi r cubed. The surface area, on that it says A, that is representing surface area, because you can't have an area of a three-dimensional shape. That's not a thing. So the surface area of a sphere is 4 pi r squared. I think a cube you could figure out. Okay. The volume is, E is in edges. I think that's what they're using for E, the edges, cubed. So I don't know, if you don't like an E, you could throw down an S for sides. So if we take the sides and cube them, the surface area of a cube, there's 6 equal sides, so 6 times the area of one side, which would be S squared. The volume of a cone, they love using conical piles. Conical pile? So a conical pile, anybody been over to the gravel pits? I'm sure you all just do that in your spare time.
That's my favorite place to go.
So, over there they have this like, there's like a, no. There's this belt. And they just keep dumping gravel onto a pile, right? So this pile is in the shape of a cone that keeps growing and growing. Okay, that's called a conical pile. It's in the shape of a cone. I think the rectangle you know. All right. Okay. Tell me when you guys are done. 4/3. Yep, 4/3. 4/3 pi r squared. So here's a trick for spheres. I always remember the volume and the area, because if you're given a volume, what's the derivative of 4/3 pi r squared? 4 pi r squared.
No way. Wait, is there a reason for that?
Sure, there's a reason for that.
Wait, do you know it?
The
Derivative of the volume.
I've never studied the surface area of a sphere before.
So it's like actually a little bit crazy.
It's pretty cool, right? That's just how I remember it. I don't know if there's actually a relationship, but
I don't know. Does it work for the cone though? For the area?
No. The surface area of a cone? Well, since you asked, I happen to know this off the top of my head.
Oh wow.
Is 2? No, not a 2. I'd like. It's pi r times L, a lateral height, plus the base of a circle is just, or the base of a cone is a circle, pi r squared. I don't think you'd see that though. Yeah, it's just a sphere. I don't know if there's. Oh, so circular things. That's true. I never noticed that. I can't believe I didn't. That's shocking. Interesting. Okay. All right, let's give this a go. You ready? Okay. So, question number 1. This is going to go like super slow this first time. Okay, so it says we've had this circle enlarging. Okay, so a circle, so all I can think of is like, we got this pile, this like puddle of water, and it's dripping, and it's progressively getting larger. Okay, and it's a perfect circle, getting larger. Good, right? All right, so the first thing it says is find the rate of change for area. Okay, and it has to do with respect to r. Okay, so meaning we're going to have an equation that has an r in it. Okay, so the first thing that I want to find is, anybody happen to know the area of a circle? Okay, so for this question I would say, all right, well the area is pi r squared. So anytime I want to talk about a rate, all I have to do is derive the given formula. Okay, so if I derive the a, what is the derivative of a with respect to time?
D of a over
dA dt. Okay, what is the derivative of pi r squared?
2 pi r.
2 pi r. And then what do I need at the end of this?
D
d r dt, the letter I just derived. Oops, dt, my bad. dr dt. Okay, so every time I derive any letter, if I'm doing a rate of change, I need a dr dt, dv dt, ds dt, whatever it is. Okay, so this is a rate of change for area. Okay, it is with respect to the radius. Okay, so now question B, or part B, says, okay, now we're going to evaluate the rate of change of the area when the r is equal to 5. Ooh, that's a misprint. And the, hold on, that's not making any sense. Let's just change this. We're going to say, and the d, hold on, I can't step on it, dr dt is equal to 10. It's not gonna say. We'll do. What I'm gonna do is, with the short amount of time, I'm gonna pull out the homework, and we'll start working on the homework after this. Together.
So is there a difference between the r equals 5 and the second?
So, yeah. So the r would be, so if the circle is getting bigger, okay. So we would know that when the radius is 5, the rate of change would be 10. So that would be given information. So now we can find the rate of change of the area. Okay. So all I would do is just literally do a plug and chug at this point. So I have 2 pi, the r is given as 5, the dr dt is 10. So if I do a little, so it would be 100 pi, right? 100 pi. So the volume, I wish they had some units on here. Let's just say it was in inches. Okay, this area would be expanding in 10 pi inches squared per, let's say, second.
This would be the area of the rate of change.
Right, so the area is getting bigger at that rate. Okay. All right, so let's go to the homework. And we're going to start by doing this together. So you can write this down on a sheet of paper or whatever.
Can we put these in our notes?
But
Put these on the assignment.
that's a good question. Let's do this. Would you prefer to have these in your notes than on
I
a...
feel like I'd rather have these in my notes.
Okay, then why don't you write it in your notes, and then whatever we don't do will be homework. Okay, or I might just give you 1 or 2 problems. We'll see where we're at. Ooh, I don't want to do question 1 first. Sorry, I'm going to skip straight to question 2 first, because question number 1 has a slight trick to it, so I don't want to start on that one. Okay.
Wait, so we're not doing one?
We will do 1. But I'm going to come back to it. I just don't want to do 1 first.
I can't focus today.
Okay, so it says, so maybe in some quick words on your notes, so this is, water is leaking onto the floor into a circular pool. Oh, I was totally just saying that. So a circle is expanding. I swear I didn't even think of that. I didn't even read this. This is my first time I've read this. The radius of the pool increases at a rate of 9 centimeters per minute. How fast is the area of the pool increasing when the radius is 8 centimeters? Circular pool. I haven't seen too many circular pools lately, but that's cute. So we'll see where we land here. I'm not going to say that I'm going to assign all of them, or we're going to see where we land. Maybe there'll be 1 problem.
Yeah. And it's going to be like the hardest one that we have no idea how to do.
It might be question number 1.
It's going to be question number 1.
I don't know. All right. So, okay, so before we start this question, we need to kind of think about what's happening. So we have this circular pool, it's expanding, and the thing that we're trying to figure out is how fast the area of the pool is increasing. Okay, so if we're talking about the area of a circle, what is the equation we're working with? Okay, so we're working with the area. Whoa, sorry. The area is pi r squared. Okay. Now, the second thing I want to do before I start deriving this is start filling in the information that they gave to us. Okay, they said that the radius of the pool is increasing at a rate of 9 centimeters per minute. Okay, so when they give me a dr, a rate, what are they giving me? Okay, a dr dt. So dr dt is 9. Does everybody understand where that's coming from? It's a rate, so it's always a dr dt, a dx dt. It's a something dt. Okay, and it's referencing the radius, so dr. Okay, the other thing that you always need to think about when you're talking about a rate is the rate making the thing expand, get bigger, or is it making it smaller?
Bigger.
Okay, so if it's making it bigger, then we're working with a positive number. If this would have been a scenario where it was decreasing and getting smaller, my rate would be negative. Okay, so it's getting bigger. Okay, what else do we know? When the radius is, sorry, don't want to keep doing that. Okay, sorry, when the radius is 8. Okay, so when the r is equal to 8. Okay, so we're going to just derive this. So the derivative of my area equation is 2 pi r dr dt. So all I'm going to do is plug in the information that was given to us. So 2 times pi times 8 times 9. And we can...
144. Is that right?
72? Yeah. 144 pi, right? Okay. Now, I want to make sure that I label this correctly. What am I finding? An area, right? So if I'm working with an area and we're working in centimeters, how do you say that? Centimeters squared. And since it's a rate, I say per minute, per time. Okay, how do we do on that one? That was pretty close to the last question I just did. Let's try.
Yeah, I definitely might need it.
Let's try number 1.
Oh boy.
All right. Number 1, we're working with a square. It's getting more complicated. We have a square.
Why is it getting more complicated?
Well, I don't know. It's a square. It's not a circle anymore.
It's not a circle anymore.
So let's draw a picture. So we got this square. Okay, and the square is growing. Okay, so that the length of its diagonals. Okay, so we got to talk about diagonals of a square. Okay, are increasing at a rate of 6 meters per minute. How fast is the area of the square increasing when the diagonals are 2 meters each? Okay, so what are the two things they're talking about? We're talking about a diagonal, and we're talking about the area. Okay, so the first thing that I have to do is I have to figure out what equation we're working with. What are they asking us? How fast is the area increasing? So I need to know what is the area of a square. Okay, so I agree that the area, oh my gosh, is, do you want to say S for sides?
Sure.
Squared. Okay, so I'm going to label these two sides as S, okay, but it doesn't say anything about the sides are increasing. It says the diagonals are increasing. Okay, so what I have to do is I have to rewrite this equation in terms of my diagonal. Like a right triangle, yeah. So, we can use the Pythagorean Theorem here. I told you this is why I didn't want to do this first. So, would you agree that the d squared is equal to s squared plus s squared?
Yes.
Yeah.
Okay.
So 2s squared is equal
Okay, 2s squared is equal to s squared. So now, I have to figure out which variable I need to solve for. Okay, which one do I want to solve for here? Remember that I'm trying to replace the s in the other equation. Okay, so I need to solve for s. Maybe I set that up too, obviously. Okay, so if I solve for s, what would you do? Hold on, I gotta solve for s first. So, divide by 2. I like 1/2. I don't know why. Do you like dividing by 2 better?
No, I like 1/2 better.
It's gonna come out the same. I don't know. Whatever. I'm sorry. I don't know why I just felt like doing that. I'll just rewrite it. Sorry. Okay, and then the s is, I don't know why. I just had this thing I felt like I did. Okay. And then what do I do next? Square root it. Okay, so the s is the square root of d squared over 2. Okay, so now that's what I can replace the s with in the area equation. So, I'm going to write this. I'm just going to go arrow, because Dyson likes arrows. A equals the square root of d squared over 2 squared. Okay, which can be simplified, right? Because you got a square root being squared, so the area is actually just d squared divided by 2. Because it's part of the area equation. Area is s squared.
Because we're plugging in that for s. Okay, that makes sense to me.
Right? Yeah, sure. Okay. Alright, so we have our equation. Before I derive this, I want to write down the given information. They said that the diagonal is increasing at a rate of... So what is the 6?
Oh, yeah, duh.
What is the 6?
The rate?
The rate. It's a dd dt. Okay? So this statement right here says the diagonal, right? The diagonal, so I'm using d to represent diagonal, is increasing at a rate. So that's a dd dt of 6. dd dt. Okay, what else did they give us? What is 2? The d is 2. Alright, let's go ahead and do this. You ready?
Oh my gosh.
Okay, the derivative of a. It says it in a sentence.
Oh.
So dA dt. What is the derivative of 1/2 d squared? You see why I wanted that 1/2 out front? So, what did you say? 2d over 2, which cancels the 2's. So d, right? Is everybody okay with that d? For the derivative. So when I derive d squared over 2, 2 times 1/2 is 1, and then I lose 1 from the exponent. Okay, what do I need at the end of this?
Because they derived.
Derive it. Derivative of...
When you derive it, wouldn't it be minus 1/2 d squared? Oh, it's 1d. Okay, never mind. I did my math wrong. My basic.
Yeah. Okay, so then d dt, right? Because we derive d, we have to say times d dt. Okay, so now I'm just going to plug in the stuff they gave us. So really I just got, 2 times 6.
So we could have just multiplied the 2 again.
Yeah, but how would you have known that from the beginning?
Because we're smart.
So, I have to label this. This is a real-world scenario. We're talking about the rate of change of the area, so we need to label it as
Meters squared
meters squared per minute. So
That's about the only part of this that I understand.
Me too. Yeah.
Is how to label it.
I think you should just not give it a test of this material.
I just don't get it.
Well, during the test, I was waiting for test.
Next week? No.
I don't.
Alright, so this is what I want you guys to do. I want you to do question number 3 and question number 4 for homework. Question number 3 is very similar to question number 2. You have the area of a circle increasing. That should be a piece of cake. Okay, question 4, you got to actually think a little bit. We got the conical pile. We'll see how that goes.